Good day, everyone. I'm Jeiel, Suay, and Ulang.
And I'm Jeiel from Albert Einstein. Join us in this video tutorial about transcendental functions. Let's crack on!
The purpose of this video is to demonstrate the calculation and help students comprehend transcendental functions in basic calculus.
Our objective is to compute the limits of some transcendental functions using table of values and graphs.
Before we go on with the tutorial, we must first define what transcendental functions are. Transcendental functions are functions not expressible as finite combinations of algebraic operations. They are represented in terms of infinite series of algebraic operations and may include trigonometric functions, exponential functions, or inverse function of trigonometric and exponential. Today, we will talk about solving the limits or the value that a function or a sequence approaches to of both exponential functions and its inverse, the logarithmic function, using table of values and graphs. Let's crack on.
Example 1. Finding limits using table of values. Suppose we have to find the limit of 4 raised to x as x approaches to 2. There are two techniques in doing this. I'll tell you the second one later, but the first technique is to construct a table of values with the value of x slowly approaching to 2. So the first x value that I've used is 1.5, next is 1.9, 1.99, and 1.999, with a corresponding y output value of 8, 13.929, 15.80, and 15.98. From this data, we can say that the limit of the function 4 raised to x is 16. Now notice the symbol right next to 2. This symbol. The symbol next to c, or in this example, 2, that signifies that the values used and or will be used in x are from the left or less than the c itself. Now, if you're still not satisfied with the limit that you have gotten, you can use x values to the other side or right side of 2, approaching but not touching 2 itself. So the first x value that I've used is 2.5. The next is 2.1, 2.01, and 2.001, with a corresponding y output value of 32, 18.379, 16.223, and 16.022. From this data, we can say that the limit of 4 raised to x from the right is 16. Therefore, we can now conclude that the limit of the function 4 raised to x as x approaches from both left and right is 16. Next example. Suppose we have to find the limit of 3 raised to x minus 1 as x approaches to 3. We just have to repeat what we have done earlier. So the first value that I've used is 2.5, next is 2.9, 2.99, then 2.999, with a corresponding y output value of 5.196, 8.064, 8.902, and 8.990. From this data, we can say that the limit of the function 3 raised to x minus 1 as x approaches 3 from the left is 9. Now from the other side, the first value that I've used is 3.5, next is 3.1, 3.01, then 3.001, with a corresponding y output value of 15.588, 10.045, 9.099, and 9.010. Now from this data, we can say that the limit of 3 raised to x minus 1 as x approaches 3 from the right is 9. Therefore, we can now conclude that the limit of the function 3 raised to x minus 1 as x approaches 3 from both sides is 9. Example 3. Finding limits using a graph. We have here a graph of the function 5 raised to x, and suppose we have to find the limit of the function as x approaches to 0. What we have to do is to follow our function and to see what value it gets close to. We're approaching this area, and therefore our limit must be equal to 1. Next, suppose we have to find the limit of the function as x approaches to 1. Again, we have to follow our function until it gets to 1. And it looks like we're coming up to this area. So our limit must be 5. Next, we have to find the limit of the function as x approaches to 2. So 2, we have to follow our function. And as you can see, we're coming up in this area. So we can say that our limit is equal to 25. Example 4, finding limits using table of values in logarithmic function. Suppose we have to find the limit of logarithm of x base 3 as x approaches to 27. Again, we just have to repeat what we have done earlier. The first x value that I've used is 26.5, 26.9, 26.99, and 26.999 with the corresponding y output value of 2.983, 2.996, 2.999, and 2.9999. From this data, we can say that the limit of the function is 3. Now, on the other side, the first x value that I've used is 27.5, 27.1, 27.01, and 27.001 with a corresponding y output value of 3.016, 3.0003, 3.0003, and 3.00003. In this data, we can say that the limit of the function as x approaches 27 from the right is 3. Therefore, we can now conclude that the limit of logarithm of x base 3 as x approaches 27 from both sides is equal to 3. Next example. Example 5, finding limits using table of values in logarithmic function. Suppose we have to find the limit of the logarithm of x plus 4 base 4 as x approaches to 60. The first value that I've used is 59.5, next 59.9, 59.99, and 59.999 with a corresponding y output value of 2.9943, 2.9989, 2.9999, and 2.99998. From here, we can say that the limit of the function is 3. On the other side, the first that I've used is 60.5, 60.1, 60.01, 60.001 with a corresponding y output value of 3.0056, 3.0011, 3.0001, and 3.00001. And we can say that the limit of the function is 3 again. We can now conclude that the limit of the function logarithm of x plus 4 base 4 as x approaches 60 from both sides is 60. Example number 6, finding limits using a graph. We have here a graph of the function logarithm of x plus 2 base 3, and suppose we have to find the limit of the function as x approaches to 1. Again, we just have to follow our function on the graph, and we want to see what value it gets close to. Here, we're coming up to this area, so the limit of the function as x approaches to 1 must be also 1. Next, the limit of the function as x approaches to negative 1. Again, we just have to follow the function, and here. So the limit of the function as x approaches to negative 1 must be 0. Next, limit of the function as x approaches to 25. We just again have to follow the function. As we can see, we're approaching this area right here. So the limit of the function as x approaches to 25 from both sides is 3. Some of you might still be asking, Jeiel, what's the second technique you were talking about earlier? And some of you might have noticed it already. But the second technique I was talking about was the substitution method. You just need to substitute the value of c to the value of x on the function, and voila, you now have your limit. Ready to evaluate some limits? Let's move on to a short quiz. To sum up, the limits of transcendental functions or non-algebraic functions can be computed and analyzed using table of values and graphs. Using the table of values, we can distinguish a numerical quantity at which function approaches to or its limit.
Thank you for watching this video.
We hope you have learned something about transcendental functions.
See you on the next video. Au revoir.